Good evening, Masrita.
Good evening, sir.
But today we are going to discuss about alcohols, phenols, ethers. Okay, so which chapter we are going to study, ma? We are going to study about here alcohols, phenols, and ethers. Okay, so first we'll discuss about the alcohols. First we'll discuss about here alcohols. So which we can call as alcohols, ma? So what is mean by the alcohols means here in alkanes. So one hydrogen atom is replaced by the OH group is called as alcohols. So what is mean by the alcohols means here in alkanes one hydrogen atom is replaced by OH group is called as alcohols. So what is the general formula of the alcohols means here CN H2N plus 2 O CN H2N plus 2O is called as a general formula of your alcohols. Okay, now here, so based on the number of OH group, we have a different types of the alcohols. What are the different types of the alcohols we are having means here? One is called as a monohydric alcohol. So what is meant by the monohydric alcohol means the compounds which contains only one alcoholic functional group is called as a monohydric alcohols. Okay, which we can call as a monohydric alcohols. The alcohols which contain only one OH group is called as a monohydric alcohols. So what are the examples of the monohydric alcohols means methanol, CH3OH. Okay, so this also we can call as a alcohol. This also we can call as a methyl alcohol. This also we can call as a methyl alcohol. Okay, and another one is C2H5OH. So this we can call as a ethyl alcohol. Ethyl alcohol. Okay, so what is another one means here? Propyl alcohol. So this we can call as a propanol. Okay, propanol. And so one more we can write as here isopropanol. Okay, isopropanol. So all these are the different examples of monohydric alcohols. Okay, and dihydric alcohols. Dihydric alcohols. Dihydric alcohols. Sir, which we can call as a dihydric alcohols means so which contains two OH groups is called as a dihydric alcohols. So what are the examples of the dihydric alcohols means ethanol, CH2 bond OH bond CH2 bond OH. So this we can call as a ethylene glycol. Ethylene glycol. Ethylene glycol. Okay, this also we can write as a so ethane 1,2 diol also we can write. What is IUPAC name means here? Ethane 1,2 diol. Okay, so this is an example of here dihydric alcohol. In this only, so phenol related also we can study. So what is the related phenol related we can study means here? So one is called as a catechol. Catechol. OH bond OH. If two hydroxy groups are attached to the benzene ring, mean that we can call as a dihydric alcohol. So this also we can write as a catechol. Okay, and another one. If the two OH groups are present at so one is present at my here 1,3 position. 1,3 position that we can call as a resorcinol. Resorcinol. Okay, and two hydroxy group so are present in opposite direction. Here one OH and here also one OH is there. So this we can call as a phenol. This we can call as a phenol. Okay, and trihydric alcohol. So what is the example of the trihydric alcohol means here? So trihydric alcohol is trihydric alcohol. Okay, so what is the example of the trihydric alcohol means glycerol. Glycerol. Sir, what is the molecular formula of the glycerol means here? CH2 bond OH bond CH bond OH bond CH2 bond OH. So this we can call as a glycerol. Okay. Now In alcohols, in alcohols, OH group is attaches with OH group is attaches with sp3 hybridized carbon atom. sp3 hybridized carbon atom. Okay, in alcohols, OH group is attached to sp3 hybridized carbon atom. Okay, so here, so what are the examples of the sp3 hybridized carbon atom means here? Now only we had seen methanol, ethanol, propanol, isopropanol. So all those are, if you observe, means in that one, OH group is attached to the sp3 hybridized carbon atom. Okay, so generally some other compounds also it is there. So what are the other compounds means here? Benzyl alcohol, CH2OH. In this one also, OH group is attached to the benzene here, sp3 hybridized carbon atom. Okay, in benzyl alcohol, OH group is attached to the sp3 hybridized carbon atom. In allyl alcohol, CH3 bond, so CH2 double bond, CH bond CH2 OH. So this we can call as a allyl alcohol. Okay, this also we can call as a allyl alcohol. Okay, in this one allyl alcohol also OH group is attached to the sp3 hybridized carbon atom. Okay, and alcohols are exhibit as a chain isomerism, position isomerism, functional isomerism. Okay, functional isomerism. And let's see which isomers are there going to be exhibit means here. They exhibit as a chain isomerism. And second one is they exhibit as a position isomerism. And they exhibit as a functional isomerism. And they exhibit as an optical isomerism also. Optical isomerism. Sir, what is the best example for the optical isomerism means here? So 2-butanol. Okay, so this is 2-butanol. So 2-butanol is it exhibit as an optical isomerism. Sir, why it exhibit as optical isomerism means it has a chiral center. Due to the presence of the chiral center, they exhibit as a optical isomerism. Okay, so that's why alcohols also they exhibit as a optical isomerism. Okay, next, all these are the different types of the isomerism. Next, we'll see the preparation of the alcohols. How we are going to prepare as an alcohol? Preparation of alcohol. Preparation of alcohols. Okay, so what are the methods we are using as a preparation of the alcohols? Last chapter also we studied. So from alkenes we can prepare as alcohols now. From alkenes, that means CH2 double bond CH2. If the alkenes are, it undergoes to the addition of water molecule. If it undergoes the addition of water molecule means it forms as a ethyl alcohol. C2H5OH is going to be formed. Okay, and second one. So when it is treated with the concentrated sulfuric acid, H2SO4, then hydrolysis reaction, H3O plus. That is also it forms as a ethanol. And what is another method means here? When the ethene is treated with so oxymercuration and demercuration reaction. That means Hg2 plus in presence of H plus. Oxymercuration demercuration reaction. By the oxymercuration demercuration reaction also alkenes are converted into the alcohols. So what are the other method we are using means here? So hydroboration oxidation reaction. Okay, sir, what is the reagent we are using in the hydroboration oxidation reaction means we are using as a B2H6 in presence of tetrahydrofuran. Okay, and in presence of peroxide H2O2OH minus. So this we can call as a hydroboration oxidation reaction. So by using this reagent also we can convert the alkenes into alcohol. Got the clarity, Sriyuta? Okay. Yeah. So all these reactions we already studied. In this one, first 3 methods are they follows the Markovnikov rule. And this one peroxide in presence of peroxide means oxymercuration, hydroboration oxidation reaction is it follows anti-Markovnikov rule. Okay, so by using these methods we are going to prepare as here alcohols. And what are the other methods we are having in the preparation of the alcohols means from alkyl halides. From alkyl halides. So what are the other methods we are using is from alkyl halides means here C2H5Cl. Ethyl chloride is treated with aqueous solution of the KOH. Okay, or aqueous solution of NaOH. If it is treated with aqueous solution of the KOH or it is treated with the aqueous solution of the NaOH also, it is converted into ethanol. C2H5OH is going to be formed. Okay, ma? And so what is the other method we are using is from amines here, from aldehydes. Okay, so this from aldehydes here. So what are the aldehydes means CH3 bond CHO. Okay, CH3 bond CHO. So I'll make you clarity here. First, let us see. Same question. First, I'm taking as a formaldehyde HCHO. If the formaldehyde is, it undergoes to the reduction reaction. So what is the reducing agent we are using means lithium aluminium hydride. Okay, so H2O in presence of water. If the formaldehyde is reduced with the lithium aluminium hydride means it is converted into the alcohol. Okay, it is converted into methanol CH3OH. Okay, and if the formaldehyde only treated with Grignard reagent, what is the Grignard reagent? CH3 bond MgBr, and it undergoes to the hydrolysis reaction. H3O plus. H3O plus. Okay, so whenever it is treated with methyl magnesium bromide and formaldehyde, it is also formed as here ethanol C2H5OH. Clear? Are you getting my voice, Srita?
Yes, sir.
Okay. No. So this is the one method. And if you take the acetaldehyde, for example, acetaldehyde molecular formula is CH3CHO. Okay. So CH3CHO. If it is treated with the, it is reduced with the lithium aluminium hydride. If it is reduced with the lithium aluminium hydride means it forms as a ethanol. OH is going to be formed. Okay. Same thing if it is treated with the Grignard reagent. If the acetaldehyde is treated with the Grignard reagent means it forms as a CH3 bond CH bond OH bond CH3. It forms as a 2-propanol. In this one, first one, ethanol is called as a primary alcohol. Okay. And this we can call as a secondary alcohol. That we can call as a secondary alcohol. If you take as acetone, CH3 bond CO bond CH3. If the acetone is, it undergoes to the reduction reaction. If it undergoes to the reduction reaction means it forms as a secondary alcohol. CH3 bond CH bond OH bond CH3. Okay. Now, when the acetone is treated with methyl magnesium bromide and H3O plus, that means reaction with the Grignard reagent. If it is treated with the Grignard reagent, it forms as a tertiary alcohol. What it going to form as here? It forms as a tertiary alcohol. Here, when the formaldehyde is treated with the Grignard reagent, means it forms as a primary alcohol. If the acetaldehyde is reacts with the Grignard reagent, means it forms as a secondary alcohol. If the acetone ketones are react with the Grignard reagent, means it forms as a tertiary alcohol. Now we got the clarity.
Yes, sir.
Okay. Next, what are the other methods we are using in the preparation? Means here, from carboxylic acids. Okay, are COOH. Okay, or CH3COOH, acetic acid. If the acetic acid is reduced with the lithium aluminium hydride, okay, if it is reduced with the lithium aluminium hydride means it is converted into ethanol, CH3CH2OH. Okay, and esters also, CH3 bond COOCH3. Okay, COOCH3. If it is reduced with the lithium aluminium hydride also, it is formed as ethanol, C2H5OH. Okay, and same ester, it undergoes to the hydrolysis reaction, CH3O plus. It undergoes to the hydrolysis reaction means one is formed as a acetic acid, CH3COOH. Another one is formed as a methanol, CH3OH is going to be formed. Clear?
Yes, sir.
Okay, so all these are the different methods, and one more method also it is that from amines also we can prepare as a alcohols. From amines also we can prepare as here alcohols. So what is the amines? Means for example, ethanamine is there. CH3 bond, CH2 bond, and H2. If it is treated with the nitrous acid, H and O2. If it is treated with the nitrous acid means it is converted into ethyl alcohol, C2H5 OH plus N2. Okay, OH plus N2 plus H2. No, H2O is going to be formed. Okay, so from the amines also we can prepare as here alcohols. So all these are the different methods we are using in the preparation of the alcohols. What are the physical methods in the preparation of the alcohols? What are the what are the physical properties? Physical properties and some other methods also it is there. So in this one, methanol also it is there. Preparation of the methanol. So how you are going to prepare as a methanol means when the methane is, it undergoes to the oxidation reaction in presence of zinc oxide and chromium trioxide, CrO3 here. Okay, when the methane is, it undergoes to the oxidation reaction in presence of zinc oxide and chromium oxide. It forms as a methanol, CH3OH. And one more also it is there, ethyl alcohol. Ethyl alcohol. How we are going to prepare as an ethyl alcohol means ethyl alcohol can be obtained from the sugar cane. Okay, sucrose. Sugar cane is containing here sucrose. What is the molecular formula of the sucrose? C12H22O11. Okay, C12H22O11. This we can call as a sucrose. When the sucrose is, it undergoes to the hydrolysis